Hey guys, this is S2 again, back for another episode of the amazing Project Euler. Yeah, that's what we're doing, Project Euler. So I haven't gotten a huge number of views on the first one. I mean, again, my channel's super small. I plan on doing more of this and then kind of devoting a series to succeeding in your career as well as computer science in general. So hopefully that will pick up some traction. Keep a lookout on that. Um, In the meantime, I'll just pull up Project Euler's webpage here. We'll see what the second one is. Apparently I gotta sign in. I don't remember this. Let's just hope that it was my email address. It's probably not gonna be my email address. We'll try it anyways. Shit. Yeah, that wasn't it. Um, hmm. Maybe we should just not do Project Euler, because apparently this is horrible. Hey, that worked. Cicada God? 33 minutes? I don't know what that means. I don't know what any of this means. Go to first post for whatever. Even Fibonacci numbers. Each new term in the Fibonacci sequence is generated by adding the previous two terms. By starting with 1 and 2, the first 10 terms will be numbers. By considering the terms in the Fibonacci sequence whose values do not exceed 4 million, find the sum of the even valued terms. So we're going to want a Python script, since Python is our language of choice, because it's amazing. No, I'm just kidding. It's not the best language for really high-level enterprise software, but when it comes to just learning coding and doing small tasks and doing these kind of challenge things, it's great for that. So we will create new empty document, give it a Python extension, hit F2 on it, open it in Sublime, which is a great text editor and automatically does syntax highlighting for your file extension. So when it comes to Fibonacci sequence, we have first num equals 1, second num equals 2, because you always need two numbers to start with for this kind of series generation, I guess. So we need to add these two. We need to print them out. So we're going to do this. This is highly inefficient coding. I forget how to do for statements in Python. So we'll just look this up real quick. I'll do it on this screen so you guys can see what I'm doing. The art of Googling is also a very important skill when it comes to computer software. And apparently I just Googled Google. You don't need to do that. Just type in your message there. So for I in range Python. This is the one I have an example of it in here. We'll just copy this one. And input -1, and I forgot that goes. So if you put in range 10, it goes from 0 to 9. So 4 score and 7 fours ago. So just to show you what this is doing, we will print n, and we'll put 4n in range 10. So I'm pretty sure this will print 0, 1, 2, 3, 4, 5, 6, 7, 8, blah, 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 up to 9. So to run our script, we open up a terminal. We will open up a terminal. There's one. I really should download a custom terminal. That'll make things go better. Find out where we are. Pretty sure we go to the Euler directory. Then we run Python num2.py. Okay, so these were our first two numbers that we printed, and then 0 through 9. gonna work because these values need to change. So we'll do I, do J, then we'll do K. It's been a while since I've done a Fibonacci problem. I may probably edit this out as I stumble through this. But I know your K is going to be equal to I plus J, and then J equals I equals K, print K. Pretty sure that's all you need to do. Name first num is not defined. Print first num. I'm just, oh man, I was so good at coding. Sorry about that. Alright, so here's our Fibonacci sequence. We have 1, 2, 3. 2 plus 3 should be. This is wrong. I equals J. And then J equals K. So that's definitely not the Fibonacci sequence, but maybe that can be the S2 sequence. I mean, it's kind of cool. It's kind of got some interesting commonalities in it. I mean, it works up to 3 plus 4 equals 7, 4 plus 7 equals 11, 11 plus 7 equals 18. I mean, it's kind of a Fibonacci sequence, except this term is messed up. Whatever. Whatever, we fixed it. So, 1, 2, 3, 5, 8, 13, so 1, 2, 3, 5, 8, 13. Whose values do not exceed 4 million. So maybe we should just put K equals 0 here. Pretty sure there's while loops. While loop Python. So anytime you want to do something repeatedly, lots of times, just throw it in a while loop. And then you have your while loop set to the condition of what you want to check on. It's while true. That's it, huh? That's all you got to do. While K is less than a number, 4 million. One, two, three, 1, 2, 3. Is that gonna work? It should work. I was gonna check it there. Whatever. So we need our fib sum equals 0. We need to keep track of what we're doing. So if we gotta check the L, it's still good in that sense. If K modulo 2 equals 0, this is basically just stating if the number is 0 or even. Because find some of the even value terms. Fib sum plus equals numbers. That number will be K. And we don't really need that semicolon because this isn't JavaScript. So while K is less than. This will actually do this when this number is higher. Do I want to do that? I don't think I do. I think we can actually just do this. So this is gonna make sure the next term is not higher than 4,000. Auto shutdown enabled because I don't have any sound coming through this, and my mic sound is not enough. You guys didn't hear that. My Turtle Beach headphones almost shut down. So while the next term of the Fibonacci sequence is less than 4,000, because this is essentially the next term. should be all we need, right? Confirmation code. So I think we can just print fibsum here. This is going to be a huge list. Huge list. We don't really need the printout of this. Let's just trust that this is right. And this is iterative in the sense that it will probably run, I don't know, 100,000 times. I'm not sure what how many actually ends you go through before you get this term. I mean, I guess we just try it. I mean, it says this is our number. Worst you can do is put it in, and if you fail, try it again. Because failure is not really a measure of anything, because all humans fail at something. It's all about having perseverance and continuing on if you want to really succeed at anything. 40922. Check it. Oh, it's wrong. I learned a fun fact today that usually if humans fail at something 3 times, they usually give up on it. So it's all about that perseverance to be able to do it. I'm not sure why that was wrong. So we got our fibsum if k modulo 2. I mean, let's just do some debugging here. So these are definitely all. That's our sum. These are all even. 34 is in there. I mean, theoretically, you could just add all these. K modulo 2. Okay. See what we're doing. So we have if k modulo 2 fibsum equals this. But this is an even term, so we're not actually factoring this in. So we need to actually set this. This is kind of a really hacky way to do it, but so it should be this number plus 2. And if this isn't right, I'm going to feel really stupid that I shared that with you guys and then just have it be wrong. Because then it's like I don't know what I'm talking about. This should be all it is. We should just need to factor in this term because we're not factoring in the term inside of our while loop. Bam! Congratulations. This answer you gave to problem 2 is correct. We hope that you enjoyed solving this problem. When it comes to Fibonacci numbers, I'm not really sure if there's a better way to do this. I mean, usually there is a better way to do this. We're not. I mean, this just seems like it runs in ON, because this is our ON term here. And we need to calculate all the terms to determine if it is even or not. So it seems to make sense, because we're adding it as we iterate. We have our check. I think this might actually be the most optimal solution. You know, feel free to leave a comment if I'm wrong. And if so, I'll try to figure out a more optimal solution, because I'm sure you probably know. And challenge will be fun. Anyways, that's all for this one. Take care, guys.